Pre-calculus, this is the second video for 4.7 notes. On these next three problems, we have two trig functions, an inverse and a regular. Now, it might feel like, okay, inverse sine of sine, that they should just be able to cancel one another out. Here's the issue. Sometimes that happens, but it doesn't always. It is actually safer to just do the whole problem. And here's what I mean. We're going to do this inside out. We're going to do the inside problem, and then we'll do the outside problem. So first part is the inside. Sine of 4 pi over 3, that's regular trig. So I don't do any crossing quadrants out. 4 pi over 3, remember if it's over 3, we make it over 6. 4 pi over 3 would be 8 over 6, 8 pi over 6. So 1, 6, 2, 6, 3, 6, 4, 5, 6, 7, 8 over 6. Ooh, that's terrible looking. So that is a 60-degree reference. Oh my, getting real bad. Anyway, it's a 60-degree reference. I want the sine, which is the opposite, which is root 3 over 2. But sine's negative in this quadrant, because of all students take calculus. So the answer to the highlighted stuff is negative root 3 over 2. So that answers the first question, the inner question. Now, though, I'm doing the inverse sine of that. So inverse sine, if I see inverse sine, I cross out the left side. It's asking me what angle would give me root 3 over 2, but negative. Well, negative means I'm going to be down in the fourth quadrant. But it's going to be the same reference angle, 60 degrees. So the reference angle was the same, but it's just that I ended up being in a different quadrant, because inverse sine and all the inverse trig functions have those restrictions on them. So the angle to get to there would be negative pi over 3. So while the reference angle was the same, it is not the case that I just crossed out the inverse sine with the sine. So you've got to be careful of that. Same idea on letter K. Again, I'm going to work the inner part first. This is regular trig. This is stuff we've been doing. So cosine of negative pi over 4. Well, negative pi over 4 would be back 1/4. The cosine, or the adjacent, is root 2 over 2, and it's positive. So the answer to the stuff in the highlight is positive root 2 over 2. But now I'm doing the inverse cosine of that. Inverse cosine means cross out the bottom 2. So you can see that I'm definitely not going to get the same angle. It was here because that was regular trig. We don't cross out anything in regular trig, but that angle is not allowed in inverse cosine. So inverse cosine of root 2 over 2, the reference is still the same, 45 again, but it's in the first quadrant this time. So the angle to that first quadrant is pi over 4. So same reference angle, but not necessarily always the same angle. I'm going to erase these. I can do the last one, maybe. For letter L, again, work the problem in the inside first. Work these inside out. Regular tangent. Again, I'm not crossing out anything. It's just regular tangent. Pi over 3. Well, that would be 2/6, which is a 60-degree reference. The tangent of pi over 3 would be opposite over adjacent, multiplied by the reciprocal, and you end up with root 3. So the stuff in the parentheses that's highlighted is just root 3. Now, though, I'm doing the inverse tangent of that. Well, inverse tangent says cross out the left side. Since the number is positive, it's going to be in the first quadrant. The angle that gives me root 3 is 60 degrees again. So this one actually ended up with a final answer that was the original. So it is true that sometimes inverse trig and regular trig just cancel one another out, like in this case, but it's not a guarantee. So again, to be safe, just work the whole problem. Okay, for the last 3 problems on this section, I'm gonna need a little more room, so we're just gonna go to here. So this is 2a. Now I'm giving you ratios that are not root 3 over 2, root 2 over 2, 1/2. They're not the normal ones. These are going to seem very strange without the use of a calculator, but we can do them. I'm still going to do that same idea of working inside out. So inverse sine, before I even look at the number, inverse sine crosses out the left. The number is positive, so I'm in the first quadrant. Now, what is this saying? This is saying that there is some angle here, that's a question mark, such that the sine, or the opposite over hypotenuse, is 12/13. So let's just call that angle inside of there happy face. I don't know what that angle is without a calculator, and it actually turns out I don't care. The answer to the pink highlighted stuff is angle happy face. So what does that mean? That means now I'm doing the tangent from angle happy face. At no point do I actually care what the angle is, because to do the tangent from this angle, I just do the opposite over adjacent. So the opposite is 12. The adjacent, well, I just have to figure out the adjacent. I can use Pythagorean theorem. 13 squared minus 12 squared. That gives me 25. And if I square root that, this is a Pythagorean triple, you get 5. So what was weird about this problem is at no point did I actually figure out what the inverse sine of 12/13 was. It was happy face, but I didn't care what the angle was because I was just going to do the tangent from that angle anyway. Exact same logic on the next one, which is the cotangent of the inverse cosine. Oops, not there yet. Inverse cosine of 4/5. Okay, so working inside out. Inverse cosine. Inverse cosine means cross out the bottom. The number is positive, so I'm in the first quadrant. So again, it's saying there's some angle, we'll call it happy face, such that the cosine is 4/5. That means the adjacent can be considered 4, the hypotenuse 5. So again, the answer to the pink highlighted stuff is happy face, angle happy face. So now I'm doing the cotangent of angle happy face. At no point do I actually care what the angle is. This is a 3, 4, 5 right triangle, so my missing side is 3. Cotangent is adjacent over opposite. adjacent over opposite. It's the flip of tangent. So from angle happy face, my adjacent would be 4, my opposite would be 3. So at no point did I actually figure out the angle. Now for the last one, the ratio actually is one that we know, but let's still run it like we've been doing these previous ones just to show you that this does work. So again, working inside out, the inverse sine of negative root 2 over 2. Okay, so again, I'm going to work this just like we did the last two problems, even though there's other ways to do this. Inverse sine, cross out the left. It's negative, so I know I'm going to be in the fourth quadrant. There's some angle, happy face, such that the opposite is root 2 and the hypotenuse is 2. So again, the answer to the pink highlighted stuff is whatever that angle is. So now I'm just doing the secant of angle happy face. Well, secant is the flip of cosine. So secant is hypotenuse over adjacent. So I just got to figure out what the heck the adjacent is, which I can use Pythagorean theorem. So this would be 2 squared minus root 2 squared. And that's going to be 4 minus 2, which is 2. But then I square root that, root 2. So the secant, again, which is, hypotenuse over adjacent, would be 2 over the adjacent, which I just figured out to be root 2. If I rationalize that, if I multiply top and bottom by root 2 over root 2, that would give me 2 root 2 over 2. 2's cancel, and I'm left with root 2. Okay, that does it for the 4.7.